Check it, check it, check it, check it, check it, check it, check it. Hello, everybody. Okay, so I want to dive deep into the subject of voltage regulations here. And before you tune away, like, fuck that shit, son, I'm out. But the reason why I want to talk about this actually affects gaming. It's like, oh shit, bring him back in. Anyway, we got a couple of methods to how to actually stabilize a lot of this frame jitter that you get on X3D chips. And I feel like I hate to mention that guy again, right? I hate to mention him, man, but frame chasers. Motherfucker probably is like, oh, he's on my shit. But not really, because I don't know him. But if I find him, he's on my shit. Anyway, so the frame chasers always talks about the frame dip, right? The AM dip. The famous AM dip. But I feel like a lot of YouTubers don't talk about the actual reasons behind it. I feel like a lot of people just don't know how to optimize. Number one. What's perplexing about this whole AM dip legend, right, is the fact that people like frame chasers actually build that channel around optimizations. And to this day, I don't get the fact that he still haven't figured it out. And I think his mind is so stuck in the old ways of looking at Intel. Because Intel, I don't want to say it's simple, because I've learned Intel and it was kind of a bitch to learn. But here's the thing, right? When you deal with Intel, you got voltages. So you got, let's say, 1.2, whatever voltage, and you just set it and forget it. With AMD, you can't just undervolt the X3D, because undervolting actually works in a form of overclocking. Basically, the best way that I can describe it, you allow your chip to work within parameters of the heat, voltage, and frequency. So those three. So let's say frequency is heating 5.2, but it's drawing too much voltage. So your CPU will begin to clock down. Or you're trying to hit that frequency and you're hitting the heat limit. It'll begin to clock down too. But now let's just say your voltage limit is just at its peak. Your frequencies will not be boosting at that point. It's kind of like you have to trick the X3D chip to run at higher capacity. You cannot just put a fixed frequency at like 5.2 and leave it there for every, like, the 3D core and the non-3D. So you can't put just 16 cores on a 5.2, and it doesn't work that way. You can do this on the 9950X, or you can do it on 7950X, or basically any non-3D chip, you can do it. Maybe in the future you're going to be able to do it with 9800X3D, or 9950X3D, or 9900X3D, but we don't know. So anyway, let's talk about the 7950X3D and actual practical uses for voltage regulations, as I feel like a lot of people just don't talk about it, and I'm just kind of dumbfounded by the fact that frame chasers could not figure that shit out. But I think it's just because the dogmatic side of people does not allow them to actually dive deep into AMD platform. AMD platform is fine. The more that I learn it, the more I'm like, man, this shit is fine, man. It just, you have to do a lot of other shit, but it's fine. So, and I'll talk about it. So let's start at the most basic one. When you go in BIOS, right? Setting load line calibration levels for the SOC is extremely important. Extremely, bro. So like putting it at level 1 on ASRock, Taichi, X670E is imperative, man. And for the non-English speaking imperative, very, 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 very important. Very, very. And and then setting the VCORE load line also to level 1 on ASRock. What do I mean by a level 1? A level 1 essentially is a flat curve, as flat as possible. So if you think of like the line, let's do like a paint so I can paint, bam. So let's say this is what you want out of voltage. And it's actually probably going to be like this. Not a straight line, it's going to be a little fluctuations here and there, but it'll be as close to a flat line as possible. What you don't really want is this, as it approaches higher frequency. So let's say you want to reach 5 gigahertz here. And this is, let's say, I don't know, something small like 3. And as you approach it, you get a lot of V-droop. And that's basically what most of the V-droop is. Once you approach the higher frequencies, to reduce the load on the CPU in terms of voltage, not as much as frequencies, but the voltage, you'll begin to V-droop. The famous voltage droop. Droop is like a, like a flop. So it begins to flop. When you keep it straight, like this would be more of a flat curve. And on ASRock, this is level 1. This would likely be the bottom portion, with the V-droop, would be like level 3. So here's what you need to do. Once you go on BIOS, there is a section that says external voltages. I'll show you in a second. So probably probably this one. Perfect. So here's what you want to do. This is a default level, level 2 and level 3. What you want to do is you want to change the CPU load line calibration to level 1. With the level 3, for the SOC, it begins to do this, as you can see. And this is level 1. So exactly what I'm talking about. So what you want to change is to this, to level 1 for the CPU load line, and you want to change the SOC to level 1 as well. One thing to keep in mind, on other motherboards, level 1 could be an actual positive curve going up. You don't want this. Make sure you find the equivalent of level 1 for your brand of motherboard. Otherwise, you'll be feeding more voltage to your CPU than you actually need, like more than spec. When you start hitting higher frequencies, and once you start hitting higher frequencies, you get higher temperatures. And once you hit higher voltages, because you're pushing them further, you'll actually will have a detriment to your CPU, like damaging detriment. So keep it as flat as possible. So what it does, it keeps you from going too low, but also keeps you from jumping voltages up when you don't need them. So essentially, you might have a little bit higher voltage while idling. Not always, but sometimes. Here's what I show you in my case. So right now, system is more or less light use. I'm just recording in NVIDIA overlay, and I'm doing the Cubase recording. So right there, as you can see, let me reset it because I was starting. This is about normal. This is okay. That's okay. I mean, it could be lower. Granted, it can be lower, especially when you idle, but it's still 48 Celsius on the CPU. So it's perfectly fine. I actually run 48 Celsius while doing absolutely nothing. And now that my AC turned off, the voltage just kind of went down too. So I think once you have your power lines being utilized more, it'll kind of throw voltages a little bit up and down. And I'm running the power conditioner, like a $700 power conditioner that basically filters out a lot of other like static and noise, and keeps the voltages from going up and down, up and down. So in my case, it's probably the best case scenario. You may have a little bit more fluctuations, but that's perfectly fine. You can see it like I actually went to a minimum of 0.8 at one point. So it still allows it even at the level 1. Mine is actually set to level 1 and level 1. So my stuff does stay pretty equal to what I need. So next point is you want to make sure that both of them are set to level 1, and just doing this without any kind of curve optimizer will actually prevent most of the stutters. And I'll include like the pictures for how to set up your system, how to actually set it up. I mean, here I'm using, here's how I have it set up right now. Level 1, level 1. And then I set this voltages manually, because what I've noticed with ASRock, if it's set an auto, it actually will put it at like 1.06. 1.06 and 1.82, I believe. This one stays pretty stable at 0.750, so I'll leave it auto. But level 1 will equal out the other portions of the voltage, and you should have it that way. The important part about SOC load line calibration, when you set it to level 1, your SOC changes a little bit. When you have level 2 or level 3, like level 3 is default, you have quite a lot of V-droop on SOC, which can and will result in stutters. Because once the voltages for the SOC go down, your memory begins to choke. So here, by default, I had 1.25, and that's like, once you set the AMD profiles, once you set, DDR 5-6000, but I actually set like through the DRAM profile configuration, I set the expo, it defaults to 1.25. With the load line level 1, I can set it lower and set it to the value that it was giving me with quote-unquote V-droop values. So, prime example. When you run expo with level 1, you're getting 1.245 actual voltage, which is okay. I mean, that's really close to what you're requesting. But when you run stuff with level 3, this is level 3, how it's set as default. Most people don't ever touch this. So you have 1.25 is what you're requesting. So same stuff is here. So like you'll set up 1.25 here because it just defaults to it. You don't want to touch it. The actual voltage would be 1.235 on the SOC. So when you set it to level 1, I did proportions trying to figure it out. So when you set it to level 1, it's actually now drawing 1.245, increasing the heat of your CPU. That in some cases may be the key between running stable and unstable, because this is like an undervolt essentially. At level 3, this is like an undervolt on the SOC, which is fine, right? But because the level 3 SOC fluctuates so much from the load levels, this can actually be bad, because now it's not just 1.235, it can go lower. It stays supposedly fixed in a HW info 64. Let me see, where is it? SOC, where are you? Okay, so that's voltage. I don't see it. Okay, there you go. So this is level 1. I had to do a little bit of math, as you can see. So what I did is I figured out basically like that this was an X here. I had no idea what this value is. I didn't know what to request at level 1. So what I did is I did a proportion. I saw at level 1, that was requesting 1.25 and it was giving me 1245. That I knew for sure because it would show up here at like fixed level, quote unquote. But here I was like, I could run it before at 1.235 was level 3, even though it's like fucking moving around a little bit. So I was like, let me set it to 1.235. But what exactly voltage do I need to set in bias? And it came up as 1.24119. And you can't really set, I believe you can set a third decimal point, but I was like, let me try 1.24. So as soon as I tried 1.24, like here, I got 1.235. But now it's fixed, basically. So it's a flat line now. So now I am benefiting from level 1. And that's what you want. Same stuff with CPU load line calibration. Ideally, VDROOP can decrease your temperatures, but it's not good for the curve optimizer. It is actually okay for running stack, but games like Radionaut will test that theory. And they will test it to the point where you will crash, even while running stack at times. Not so much crash as in you'll crash to desktop, you'll hold the game substantially enough where it's not going to be comfortable. You go from playing the game to going, hey, what the fuck is going on? And that right there, that little window, right? Like, that's what bothers me. It's not overall experience, it's just the momentary experience. So, prime example, I'll show you here. In this video, it's minus 15. And this is very typical. When you have default levels, so default level for the CPU load line is 2, and for the SOC on ASRock is 3. So level 3 and level 2. CPU level 2, SOC level 3. And what you'll see in the video, it works just fine on 15. 15 is like a small curve shaper value. Pretty much 90%, 92% of 7950X3Ds can do minus 15. So that's why all these YouTubers are like, oh, just set it minus 15, it's all good. What they don't talk about it is the fact that you gotta have load line levels correct, or even that will crap out. Not necessarily right away, but check it out. So this is minus 15. And it happens right here. So basically right there it holds. You can see the frame dips, boom. And then it's like back to normal. And that's not what you want. And this is default load line levels. This is another moment. Like minus 30. This is heavy, pretty heavy curve optimizer. Not every CPU can do it. This one can actually do, and I'll talk about why. Even at default load lines. Here you can see like a pretty, see right there, huge frame dip to like 14 FPS and 0.1%. And but that is still minus 30. So you can say, well, it's minus 30, it's all good. No, it's not. This is not the reason. The reason is the voltage fluctuation. This is minus 20. Boom, right there. And that hold right there is probably even worse than minus 30. So it was not making sense because it was happening on minus 15, minus 20, minus 25, minus 30. And this is basically after voltage fix. Obviously, this is still loading. I did minus 20, minus 25. I feel like minus 30 can throw voltages down because it's already hitting like the bottom of the CPU like metrics. Some CPUs can do minus 40, but are they testing the really CPU intensive games? I'm not sure. There's a great channel, I think it's Game Tech Reviews. Great channel. And he actually tested, like he said, you can set minus 40, but as long as your load line levels are as flat as possible. Now, at first I didn't test it because I needed to get a better understanding rather than just setting shit. But look at the frame time. Just a complete flat line basically. It was like once in a while you get a little ping, and that usually happens when you approach areas where the enemies have not spawned in. I feel like a lot of these games they spawn in enemies later, even though they're supposed to spawn in before. It's almost like it's triggering the spawn. Maybe I'm wrong, but it happens during certain points of the game. Like was this game specifically was ready or not? In the very beginning, once you go through entryways of the actual map, it always dips to 40 or 50, but it always happens. But in the very beginning, what you don't want to happen is for it to constantly keep dipping. But you can see minus 20 is not worse than minus 25, not by much. It kind of averages out at the end. Well, the longer that I play, I think it evens out to 99 at 0.1% lows. So that's as low as I can get. Just a normal gameplay with all this shit, just firing and all that. And I think it stays at 107 or 109 on the 25 curve optimizer. See right there, the little jitter, but that's fine. It's tiny. It's tiny, at least for what we see on the graph. It's also rare. To have a rare little jump, that's all right. The goal here is not to have 0.1% jumping up and down. And that right there, my friends, is exactly what the frame chaser was talking about, the aim dip. The problem with it is the systems that he's testing, quote unquote, are not optimized because he doesn't know what the fuck he's talking about. Because he's so bent on Intel that as an Intel person myself, being on Intel for 12 years, I don't hate Intel. I don't hate AMD because I've been 14 years on AMD before now too. Before that. So started with AMD, went to Intel, now I'm back on AMD. You can see consistency here. In fact, with my tuned 3900K, which arguably some people will say is a better CPU because it has more cores and Windows has an advantage because Intel and Microsoft work together and blah 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 blah, I could not get the graph this flat. So I feel like the problem with a lot of reviewers on tech channels is they don't know how to tune this shit. And I am just really dipping my feet in this, but with the same mindset that I had when I had Intel. See, a little jump right there on the graph, but it's okay. It still was, it literally, the 0.1% didn't even move. And now that I'm deepening into, 3 FPS drop, oh my God, it's and that's inside of the building where the enemies are still there. So the more shit you have inside moving and shooting at you, but look how well the minus 20 curve optimizer is doing. With all that stuff, even with little, but see, it's the same pattern. Once you enter the building where the enemies are, it's almost like I believe there is a queue for them to start doing shit. And once that trigger comes in, it throws frame time just a little bit up. But not to the point where the frames are going down. So back to the point of what I was talking about. When you have experience with Intel, you can apply it towards AMD. And right there and then, after optimizing this shit, I realized it's not that difficult. You really just have to know what you're doing though. I don't feel like a lot of TechTuber channels know what they're talking about. I've seen channels talk about voltage regulations as the only reason being is I want all the voltage and blah blah. It's I want all the voltage or I want the voltage stable, but why? There is reasons for B droop. You know, there's reasons for it. When people want just flat line voltage for no reason, that doesn't really speak highly of their knowledge. And I don't mean like to insult them, but I mean like objectively speaking. The voltages have to be flat as possible if you are gaming. All the other scenarios, who gives a shit, man? Honestly, if I wasn't gaming, I wouldn't care about voltage regulations, because a 1 millisecond stutter in opening the folder is not felt, because if you're opening a folder, you have no metric. Like with games, the reason why you can see it is because you're literally watching the FPS. You're actually watching the action of every player. You're watching your own mouse hover over targets. You're watching the explosions. You're watching the interactions with the environment. And that right there makes you realize you have a stutter. When you don't game, you don't need this shit. You don't need to touch voltages. You don't need to touch, all kinds of frequencies. You don't really even need curve optimizer. You don't need it. You can run your CPU at stock and you're fine, man. I will just maybe limit the temperatures. I feel like with thermal limits here on 7950X3D, the thermal limits are lower compared to 9950X or 7950X. So I put a limit to 85 Celsius. And that's my TJ max that I set manually, which I'll include all the pictures that you can actually apply using my profiles to another ASRock board. And it'll work. You don't have to have my profile to copy it. You can just copy my settings, and that will alleviate most of your stutters. Besides, obviously, the Windows optimizations that I always talk about, like disabling, certain audio devices if you're not using them, or you are disabling tasks, unneeded like updates and stuff like that. So shit that's running in the background. But to say that AMD is garbage, it's wrong. Like when I play on Intel, I want to see if I can find that. It's an older video, but I want to find it just to show you. And this is not knock on Intel, but I feel like there's limitations here. So it's ready or not. There you go. Then we can do like even 4080. And by the way, I didn't have frame time back then. Scheiße. Hold on. Oh, no, you can actually still see it. This is 1440p, so not the best example because it takes more resources and it's a weaker GPU, but let's see. Let's see if there is one with a graph. Is that one in? Let's see, is that frame to frame here? Oh, look at that. This is 4080. Obviously different map. I mean, man, this is doing good though. This is like the optimized system when I had it. 2.3, 2.6. It's amazing. Let's see if there's any open areas, because that will make a difference. Yeah, well, I might have to retest this for this map, but see, did you see that for a second? Here, like right here. Look at frame to frame latency, the little jump. Boom, 12. That's pretty severe, man. From 3.4, and usually you can feel it in a mouse response. Not always like the graph, like the jumps are not so bad. But I'll tell you what, when I played this game, like if you kind of look at the graph, you can see little bumps. They're more frequent. But this is also inside of the building. Keep that in mind. Inside of the building, you will generate more FPS. So your averages can be thrown off. But this is great. I'm not talking shit about Intel here. Point is this. This is Intel at its tune capacity, basically at 4080, at RTX 4080 compared to 4090, and it's utilizing the GPU a lot. But 7950X3D would probably do better, and the reason why is it's very basic. The GPU utilization actually plays a huge role in how well the frame-to-frame is. So, but this is phenomenal. Like you can see like 1.9, 2.8, 2.3, 2.6. Like it's within 1.9 to like 3.5. And that's about as perfect as you can get. So if you play this game, like 3900K would have done phenomenal with 4080, from what I can see. But I don't know. I don't know if I have anything with 4090. It's been a while, man. 3070. Even 3070, man. But I don't think I had frame to frame here. Yeah. Anyway, my point is this. Both CPUs are phenomenal, I think, for actual gaming. Like 3900K and 7950X3D. It's just I had issues. I had issues with 3900K twice. And it sucks, man. I would have probably stayed on that CPU for the next 3-4 years from the day that I bought it. Well, maybe even longer. But truth is this, right? Truth is this, man. You got an excellent CPU, but you know that people can't really tune it. You gotta do it yourself. If you buy a CPU and you expect everything to work, it won't happen. It won't happen with Intel. It won't happen with AMD. You have to tune this shit. So, a couple of more points that I wanted to mention here. So most 7950X3D, 7800X3D, 7900X3D can do minus 15 offset. But start at minus 15. Make sure you set the load line levels to 1 or as flat as possible, and then begin to test with minus 15. Make sure the SOC is within spec by using HWinfo64. You want to use this. And you gotta watch it. You have to, basically. You can Alt-Tab and check, make sure this is staying pretty good. This is technically, some people say you can do 1.2 with 6000 megahertz RAM. You probably can, but I'd rather have like 100% stability, and I'm already downclocking like 500 megahertz from the designated expo profile, so I wouldn't do it. So I did 1.235 as the level 3 had, but with level 1 with those calculations that I showed you. And then CPU voltages, let me see if they actually, it shows it, but let me see where. There you go. So this is normal. I've seen with stock, maximum can go up to like 1.37, which is pretty high. But AMD is saying that 1.4 is the maximum, but TSMC, on which the CPU is manufactured, is saying the 1.2 is the maximum. I'm kind of shrugging right now, man, because who do we trust? Do we trust an AMD that sells the CPUs for a living? Or do we trust the TSMC that basically designed, the wafers for the chips on which the CPUs are manufactured? Who's right? Is the degradation that small that it doesn't matter once you go like above 1.2? Perhaps. Is it better to run your chip under 1.2 or within 1.2 range? Yeah, because you'll have less heat. So that's another thing. So games such as Ground Branch, Radionaut, Arma, like similar milsims, they all will tax your GPU and CPU, but mostly CPU, because they never utilize your GPU to 100%, unless we get to the point where the CPU is so strong that it can actually run all the tasks. So now it throws it onto the GPU side, or you're running high enough a resolution. Here's a ground branch. Just to demonstrate here, look, you got CPU utilization at like 17 and GPU at like 72. And this is like an insane resolution. This is like, I upscaled it. I upscaled it to, let's see, it's here somewhere. Come on, where is it? Just saw it. 3325 by 1871. That's it. But that was the whole point. The point was to make sure that I'm taxing GPU more than I'm taxing the CPU, because this is a CPU intensive game. And the way it's optimized is just, I don't know. Yeah, I guess other games tax, like Arma is taxing your CPU a lot. And that's why people had always issues with running even 60 FPS. It was like really good graphics cards, but it's because it's CPU bound. Like here you can see it's 60% of that insane resolution. And that's normal. So in those cases you will not get a high FPS, but you want this graph, right? Like the bottom graph that's drawing right now. You want that frame time to be as low as possible with no apparent jumps. And you can see this is pretty damn flatlined. And this was before that voltage fixed it. So voltage was still at the defaults. And it's already doing so well, but this is like a curve optimizer minus 30. So long story short, the curve optimizer is not the answer. The answer to the curve optimizer is the voltage regulation. Unless you're drawing even amount of voltage, you will have those halts in a game. You'll have games breaking. And honestly, this is what I think was happening, because I would just randomly crash even with minus 15 in random games, and I'd be like, what the fuck, man? Like, I'm not, and you know what's interesting is, like, when you crash, that overlay is still showing up. So I would like, and you know this is literally like the moment when it breaks. And when it breaks, you're like, okay, let me see the temperatures. The temperature's crazy, and it'd be like 68 on the GPU and like 62 or like 65 on the CPU. So I'm like, I am within like the thermal limits. Like, so I kept changing RAM sticks. I'm like, okay, let me try this RAM stick. Let me try that RAM stick, and blah, 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 blah. I kept doing it back and forth to realize that it's actually, bro, the SOC. The SOC voltage regulation, not the actual voltages. I can probably now can go lower in SOC because now it's a stable SOC. I don't want to, so I'm just going to leave it as such, but I probably can. But it's probably going to take me days to try to figure out, okay, is the frame time going down? Is this, as long as I'm under 1.3, that's fine. I feel like 1.25, it's very comfortable. If you go lower than this, great. If you can go 1.2 and still have that, none of this, because this is just the starting of the map. So that's fine. And also I'll tapped into the game. So like I start. So the map literally like will start. I'll be at 50 because now it's averaging out. Then I go, after I show you the settings here, like I went through settings. This is that crazy resolution. And then once I get back into the game, I reset it. Probably not right away. Probably right here. That's when I reset it. And now you can see it's like 85 is the 0.1%. And now it's like within the parameters that you should be testing. The 37, like, listen, this is still, I guarantee you this is still voltage regulation bullshit. Because it was not fixed then. And that's what you want. You want to avoid big drops that are causing this. And certain games that don't actually show issues with curve optimizer and default levels. I actually did like I uploaded it already, but let me see which one is it. This one. Like when I uploaded this, I did -30 curve optimizer, and I did a stock. And what's really interesting about this video in general, when you look at the FPS, the averages, it's the same server, by the way. So this is about as apples to apples as you can get. I literally, we the one round, the last round, and then I just went out of the server, restarted my computer, set stock levels, I think. And I went back and I recorded stock levels. Well, before I was recording -30. And when you look here, look, the average of the stock is higher than the average on a -30, even though it's supposed to be scorching it as far as performance goes. And the reason why is, once the CPU doesn't get enough voltage, it begins to, and it's like, on games like this, like Insurgency, I think Insurgency had struggled quite a lot because you can see the GPU usage is low. This is 1080p, but this is what I use. Like I run 1080p most of the time. GPU usage is low, so your CPU will be taxed more. So CPU actually makes a huge amount of difference. And X3D chips are amazing as far as this game. Dips, those are the ones, those are the points that you should be working on with voltage regulation. That's why I'm making this video. But 7950 X3D and even 7950X, the non-X3D version, when you get killed, it's such a smooth transition, almost like here, like see, like I got killed and it just like throws you back. There is no stutter. It doesn't throw you like FPS into dog shit or like 60 or like 40 or 30. It stays within that 92. And it would throw it back into like a really low number when you play with Intel CPU. And it's like fully optimized profiles that I had. Even though on Intel too, I try to keep voltages also even with fixed voltages, because it's a fixed voltage algorithm, completely different from X3D that's tied in the frequencies, the heat, and the voltage. All three of them are tied together. So what I think on Intel, you suffer from similar afflictions, because if you don't set the load line levels to something even, you may have issues. But on my case though, I know for certain that I had set mine to be as close as possible from the load line, from the load line level when you have a lot of tasks going, when your CPU is really loaded, to the idle states, to be as close to each other as possible. I can't remember. I think I ran like anyway, I'm not gonna lie because I just don't remember. But I voltage monitor this in HW info, and what I've seen is this voltage, and I never saw nothing like this. There was no like minimum drop to this. This is actually good. You want your CPU to go down, because in this case for the AMD, because your CPU is basically resting. It's not doing shit. It can draw less watts, and that's the goal. But on Intel, I had like 1.335 was the highest core VID, and I had like 1.32 to 1.28 range at all times, and that's amazing. That's what you're supposed to have, and that's why when I showed you Intel, it was like that flat line almost. But look at this. Look at this flat line. And that's still without voltage regulation. So AMD CPUs are phenomenal. But you know there is some shit that you gotta change. You can't just throw it in like frame chasers. Look at it and be like, it's dog shit, homie. Get yourself an Intel CPU. It's like, bro. For a person I had the Intel CPU, you know how much fucking tuning that I had to do in order to avoid the goddamn fucking stutters? A lot, bro. A lot of sitting around fucking pulling nut hairs out of my sack, man, you know? But point being is I figured it out, man. And it takes just time, man. Time, God. And just wasting a lot of fucking time trying to figure this shit out. Looking at FPSs. Look at that. Look at all the FPSs now, though. Lots of new FPSs. The more FPSs you get, the better the FPSs. The better you perform. Get me on your billboard for esports title. I'll sell you all the CPUs, man. Anyway, that's it. Voltage regulations, set that shit, and let me see if I hit all the points here. Oh, yeah. One thing that I didn't mention. How I set affinities. So I run process lasso, and let's say this is the process I want to run on the CCD 0, which is a 3D. So you right click on the process lasso, and then you go affinity, CPU affinity, always select, and the cores that I select are 0, 8, so like this. Basically, I disable the 3D hyperthreading, and I also disable the non-3D side of the CPU. So now I have 1, 2, 3, 4, 5, 6, 7, 8. Just 8 cores for that application. In that case, it will be your game. Hit OK. A lot of times, you'll have to restart the game or even restart the system. And make sure that this is running in your background, the process lasso. And then your game will perform amazing. If you have all cores selected for the CCD 0, which is a 3D cache CCD, so it's a chiplet basically on your 7950X 3D. Same goes with 7900X 3D. If you have hyperthreading on, you will stutter, because games just don't know what to do with the hyperthreading. So this is one of the things you absolutely need to turn off, my opinion, but based on like hundreds of videos that I watched and hundreds of experiences that I had throughout games. So then you hit OK. I don't need to do it because this is not actually the game. Now, the best driver right now for the RTX 4090 and 4080, as far as I know, for the performance side of the games is NVIDIA Studio driver 560.81. This is the best one. Let's see, actually, if it's going to show it in this. If not, I'll just pull it up. Yeah. So there you go. 560.81, but studio version, not the game ready. Game ready is just, Game ready just never seems to run stable as far as stutters go. In my case, it's 4090, but it's the same stuff. This studio driver is supposed to be very stable. So far, the best one. Even for 9950X and 7950X3D, and I'm sure 3900K. Before I ran 555.85 driver, which was the best until this one released. This one I think is like released in May or June. Now to the settings portion. I have changed some things now, and they actually allow the GPU to work even better now. One thing that I turned off right away is the threaded optimization and the trilinear optimization. So both, this is like, it's using bilinear filtering when the trilinear is not, like, it's not needed to be generated. It's like, it's kind of weird. It's basically like, it's saving you time from making textures sharper, but it's actually utilizing your GPU and CPU more. Like, it makes no sense. Maybe in the past it made sense. It was like weaker GPUs, but with stronger GPUs, it's not good. And it actually takes more resources from your system to do trilinear optimization compared to having it off. And also, when the textures become bilinear, not trilinear, not 3, but 2, they look worse, so you get more shimmer. So basically, you're making your game look worse. This may actually work in a really bad GPU scenario, and you wouldn't need trilinear all the time because you're already like at low settings or whatever. But like a normal system, even like 4060, RTX 4060, have this shit off. You don't need it. Then you got threaded optimization also off. This actually plays in tandem with disabling of the hyperthreading. You don't want all this extra, because in most cases, it's just, even though it says, how does it say? Let's say here, most newer applications should benefit from the auto select on settings. I wouldn't agree with it. I've tried Battlefield 2042, I tried Red Dead Redemption 2, I tried Insurgency Sandstorm, I tried newer titles, older titles, and they all get afflicted by the stutter, like a little jumps here. They're much more consistent. And let's go through the settings again. So image scaling off, that's kind of like a preference. You can add it if you like, but I don't mess with it. Ambient occlusion off, don't really need it. Anisotropic filtering, application control, because if you want to use it, you can use it, but you shouldn't set it globally. FXA, horrible. It makes everything kind of washed out. It's a bad anti-aliasing method. So I'll turn that off. Gamma correction is on. This is actually, by the way, this is really old. So this is why. It was pretty good at the time, but it's pretty washed out nowadays. So anti-aliasing, application controlled, transparency off, background application max frame rate. You should have it off, where you are limiting your games to certain, amount of frames, which can work for like individual game. Let's say the game is drawing just kind of like jumps for some reason into some weird, like from like 60 to 150 FPS, and you don't want that. You can limit it to 60. You get worse frame to frame latency because now completely different subject. So don't want to dive into it in this video, but I will have it off. Then you have CUDA GPU. You can specify it. If you have a couple of GPUs, you can specify this private default. I don't even know what it is. So, anyway, so I just don't use it. DSR you can use if you're upscaling in games like that I just showed, like the Ground Branch. You should have it as an ability. This is DL scaling, because if you have a 1080p monitor, it won't allow you to set anything above 1920 by 1080. But with this, it can. So you can technically trick a system into using your GPU more compared to the CPU, and that's how you do it. You would select appropriate frequencies or resolution levels, then hit OK, and you're fine. Smoothness, DSR smoothness 33, it kind of makes it more smooth. You can actually turn it off. It'll make everything sharper. So It's kind of like anti-aliasing, but for DSR, which is upscaling, but it's like you're utilizing the NVIDIA's frame, kind of like frame generations, but not really. It's, I wouldn't call it frame generation. It's, anyway, man, it's just, you can leave it at 33. You can put it at 0 or leave it at 33, which is a default. Low latency mode, I would set it to on. That's what I would set it to. A lot of games actually have that ability to turn it on, but some games don't have it, don't have that option. So if you want to set it globally, this is where you would set it. Don't set it at ultra, as it kind of like tanks the performance from what I've seen. Even though it's 4090, it kind of becomes more sluggish. Having it on is probably the best. Like Red Dead Redemption actually has that ability to turn it on, so I can do individual. And what I've noticed, like games like Radionaut so far, it's okay with having it off or having it on. With on, it's better though. It's smoother and like much more responsive. So it works for the mouse clicks also, for the how well your mouse responds to the clicks. So it kind of lowers the latency. It can bring your FPS down just a little bit, but not a lot. And actually, strangely enough, it adds GPU usage, which can actually boost FPS, but then it takes away, because of the actual additional process, can take away some of the FPS while boosting more FPS. So it's kind of like plus and a minus, salt and sugar. Max frame rate, same stuff that I was talking about, right? Same stuff. Background application. So it's a background application. Okay, never mind. So some reason you have like a monitor running at 60 FPS in the background, but you want the game on a second monitor to run at 280. I guess you can do it. I don't know why, but you can. So I guess that's the background application, max frame rate max, and that's regular game max frame rate. Anyway, so keep it off. Multi-frame sample also off. This is auto. Don't really care for it. System can figure it out on this side. OpenGL rendering. It's always gonna select your GPU anyway for the rendering, unless you have two. So I wouldn't touch it. You can change it to prefer maximum performance, and it actually will increase your response maybe by like a couple of frames here and there, but not a lot. So either way, you can do maximum performance or normal. In some cases, people are reporting that when you set this to maximum, your GPU usage will go up, like frequencies and idle states like now. In my case though, like I don't see a difference. If I switch it, it's identical, and I've checked it like 3-4 times. So I had it set at the prefer maximum performance. I don't know. I don't really see a difference. If there is any difference, I even like went and did a test where I compared this, I believe. Let's see, like I did this. I did a max performance versus so this is what? This is normal. So this was like performance mode, and I did like a reset of FPS, I believe. Let's see. I was just watching like the frame to frame to see if there's a difference. Obviously, it's a menu, doesn't fully reflect it, but even on games, I can't really tell. So this is maximum performance. So I closed it. I reopened it, right? Yeah. Oh, okay. So I changed it. I changed it to normal. Normal. Okay. And I was just watching this. If anything, like as far as frame to frame is usually the first thing that I watch to see if it changes. And I was like, okay, well, it's like within like 3.1 to like 3.9 to like 4.0, like 4.1, I guess. So like 3.1 to 4.2, somewhere around there. So then I went and I changed to maximum performance. Sometimes even the main menu can show it. Let's see. 3.8, see 4.3. Honestly, bro, this what was the last option that it shows? Maximum performance. So now it's performing worse by like a 0.1 or 0.2. You see actually like 4.4. So literally maximum performance can actually be worse. I don't get it, man, because in my case it doesn't really apply too much. Maybe because the GPU is just so strong. We're not fully utilizing it at 100% levels. But in theory, it allows to draw more watts from the GPU. But I'm undervolted, so I'm not even drawing like a full 450 out of it. In fact, as I have 3 cables connected to the GPU instead of 4, because I'm never drawing more than 400, never. I have 3 cables connected, so each cable is 150 watts each. That ATX, that PCIe cable actually. 150 plus 150 plus 150, which is 450 max. For the newer like GPUs that actually like have like a OC profile of like 600, which is insane. This is how like I feel like this is exactly how cables are melting. You're feeding too much voltage through that rail, and then the weakest point is within the GPU, because all the frequencies, all the heat, and all the electricity is being condensed on that one 12 high-powered cable, and then it just melts. So in my case, I did 3 cables just in case, because I don't need that much wattage, and then I stepped it down with undervolt, but quote-unquote overclock. So I'm like 2820 from 2805 megahertz to 2820 maximum. And you can see it in the curve optimizer. So I set, so this used to be here, like at the lower frequencies it was higher, so now it's like 300 megahertz lower per se for that voltage. Anyway, it's as long as I hit the max here, like a flat line. That's another point, by the way, guys. When you have a flat line curve here, instead of having a little going up, it's better. So now that I have 2820 or 2805, depending on the game, it's stable. And that's, my friends, is about it. Other than that, man, it's just check out my other videos, and I will leave eventually an ASRock file here to download if you would like to use it, and I will leave also the pictures so you can copy it. But SOC and voltage for the VCORE level 1 on ASRock, and
good luck, everybody!